In this experiment, we are going to find wavelength of a given laser source using diffraction grating. So the characteristics of laser source is it emits monochromatic light. It's a collimated beam, and there is a constant. It's a highly coherent beam. Now we are going to use diffraction grating, uh, which is shown here in this diagram, and which looks like this. So this is diffraction grating. So here you can see this laser spot, and this is a window. And actually, the grating, if you remember, the grating consists of a slit, and there is a opaque surface, and usually a grating is specified by number of lines per inch. So one line consists of slit and opaque surface. So if the grating says there are 500 lines per inches, it means that there are such 500 elements per inch. Now the width of the slit and opaque surface, we call this as a grating constant. So now for this grating, if you want to find out what is the grating constant, now it has 500 lines per inch. Okay, so now I want this so to find the width of this element, I'll take inverse of this. So 1 by 500 will give me the width of this element or grating constant in inches, but 1 inch is 2.54 centimeters, so we get this number, okay, which is the grating constant. Now this is the formula which we had derived in the class. So here d is the grating constant, lambda is the wavelength of light, n is the order, and theta is the angle at which we observe the specific order. So this is the experimental setup diagram. So we have laser grating, and this is what the pattern that we observe on the screen. So if you look at this, so this is the laser source, it's incident on the grating, and this is what we observe on the screen. Okay, so you can see this central spot, which is the brightest one. This is called the 0th order, and there are two spots which are the first order, second order, third order, and fourth order is pretty faint. So this is what is shown in the diagram. Okay, now what we want to do is we want to calculate lambda. So to do this, what we measure is theta. Now if you want to measure angle theta, okay, if you take tan of theta is this distance divided by this distance. So what we do is we measure these distances and these distances, and from that we estimate the angle theta. So how do we do this in the experiment? So what we do is we take one of the graph sheets, and you have to put it like this, okay, and you have to bring all the points on the line. Now what you have to do is you have to mark the center of those spots, okay, and once you mark the center of those spots for the fourth order, then you bring it back, and then you have to mark that graph sheet same as what we have done or shown in this diagram. So you will have markings on your graph sheet, and so these will be the 0th order, these two first order. So you have to write down 2x1 distance, then distance between the spots for second order is 2x2, and this is 2x3, and this is 2x4. And apart from that, you need to measure the distance between grating and screen. So there will be a thread which you can use. So you have to measure the distance from the center of this slit to the screen, okay, using this thread. So this will give you the value of d. Now once you have these measurements, you are ready to fill the observation table. So here you will write the d distance, okay, then you will write the 2x values for these first four orders, then you will divide this by 2, okay, then in this column you will calculate theta, angle theta, then here you will calculate sine of theta, in the last column here you will calculate lambda, and while calculating this you have to divide by respective order, okay. So this is one set of data that you have taken. For the second set of data, what you have to do is you have to change the distance between the screen and the slit. Either you can decrease it by 10 centimeter or increase it by 10 centimeter, and again follow the same procedure. So this will be your second set of data taken for the second value. Again you have to do this calculation. Then you calculate all these values. While doing this calculation, make sure that you do calculation up to fourth decimal place. And then once you have these values, you calculate mean and then express this in terms of angstrom. In the error analysis, you have to you have here you have done calculation of eight values of lambda. In this, you have to calculate error in all those 8 values. So suppose you got this first value lambda uh, in the first row using so let's just go back. So using this x and this d, you calculate the value you got here. Now, so while calculating error, this will be your x, this will be your d, and you will calculate error in your wavelength. Similarly, for the second value, you will use the corresponding x value, corresponding d value, and calculate error. So this is how you will do the error analysis part. And here delta x and delta d are the least count of your instruments, which are 1 mm. So it's better if you write these values in mm and then do the calculations. Just remember these two quantities should be in the same units.